to talk to you guys today about magnets and electromagnets. And are they the same, and what are the differences between them? Let's just be honest in the first beginning here, they're not the same. They react different in nature. They build out differently. Let's go ahead and take a look at this. We're just going to build a magnet here. We're going to put a hole in the center right here. When I build out a magnet, it's going to go like this. It's set. Right now, this magnet's set. When we do this, the frequency, the voltage, and the amperage are set. That won't change. It's already set in time. It will not change. It's put right into the material. Now, an electromagnet doesn't do that. We just draw this here, and I'm just going to draw little windings on it. My frequency, my voltage, and my amperage change as I want it to change. As soon as I change my frequency, I control my voltage and amperage. Now, this right here goes like this. In this right here, every time I take my frequency and I increase it, my voltage increases and my amperage decreases. Every time I take my frequency here and I bring it down, my amperage increases and my voltage decreases. That's how that works. In an electromagnet, based on the winding, if I wind it like this, I get my north and I get my south pole. Here, north and south are already built into it. That's not going to change. But here, if I wind it the opposite way, it will now change my north and south direction. Again, this is set. It will not change. This electromagnet, I can change at any time. This one I can't. What do I have to do to this magnet in order to change it? Going to have to take that magnet and I'm going to have to put a rotational spin on it. When I do that, now I have an RPM divided by 60 is my frequency. Now this will go on top of this. It is not any different than taking a square wave and putting a sine wave right over top of it. You say, well, why is that? How does that work? Because this is already set. It's already set based on what we put into it in the beginning. Now I can add this to it. You could do the same in an electrical system if you wanted to. You could take a square wave and you could put a basically a sine wave right over top of it and change the frequency in any high voltage system or low voltage system. But this is how you get something like this to change. It now rotates. As it rotates, here's the cool thing. It'll build out fields from it. Like this. Like this. And like this. So what happens? Your voltage right here in any rotating magnet will be very high here, and you'll have high amperage. Voltage and your amperage will go down like this over time. Just like that. There'll be heat here, not a lot of heat here, okay? That's how it's going to work. It's going to build out in fields. Now, what is it doing here? It's pushing against the radiant nature of your Earth itself, okay? We're in a field of very high entropy right here. So if we said the entropy was very high here, it's densely packed, it's very low here. Why is the entropy going to make a difference? Because your entropy is a direct correlation to the scalar type field that it's building out. Every time you go here, you're going to get a different frequency, voltage, and amperage that build out in your rotation. Every time. All you have to do is rotate it. Now that portion right there is more like an electromagnet as it spins. What is one of the problems when we get into this? Okay, let's take this equation here. And then we're going to go to the permeability over epsilon naught. Okay? So the derivative of the electric field is is equal to the permeability of epsilon naught. Now, oh, it frustrates me every time I hear this, and you hear it a lot in videos. Don't worry about this, this is a constant. That's a lie. Let me just tell you up front, that's a lie. I'll tell you why. Here's the Earth, here are you standing on it, okay? And here's the outside of the Earth. Epsilon naught has to do with the permeability of space. So in this space right here, we get a certain distance, right? And it's based on the electric field that's going on all around us. Now right here where we are, there's not much of one going on. But what happens if we're here? Then that electrical field, the field potential, okay, is much higher right here. So what happens now? I get a much further distance that's going on here in my field. So is this constant? No. It is constant based on where you are, but it is not a constant in nature. As soon as you go up in the atmosphere, it changes. That's okay though. They always try to cancel this out and say it's not really that important. Why? Because everybody's wandering around on the surface of the Earth. That's why, because we're not up here, we're not Superman. But this is not a constant, even though they put it in there. So what does it do to math later? It ruins your math later. This right here is why you can pull over unity and run corona motors up here, but a corona motor won't work down here. Why? Because the permeability of space is different. The amount of voltage is different. Now, this is where I don't like any of these equations when it comes to this. And I know simply all they are is they're looking at magnets the same as electromagnets, but they're not putting the full picture in front of you. And that really bothers me. So we look over here, B, and they say it's equal to 0. Why do they say it's equal to 0, this particular one right here? They say that the B field is basically a set in stone thing. That it's always going to be a circular object, right? Well, there's a problem with that. This may work in a magnet, but it will not work in an electromagnet. Why? Because energy flows. And when you go to it, your frequency, your voltage, and your amperage is a flowing voltage. Okay, it's a flowing energy. These two cannot be, or these three cannot be decoupled at all. As soon as you get into electricity, you must have a frequency, a voltage, and an amperage. No matter what you do, it will not work without them. This right here, a closed little loop, is impossible when it comes to an electromagnet, okay? It's completely impossible, okay? Why? Because as you deal with this, you are moving around this thing right here, around the wire. You're not inside the wire at any time. You're around the wire. The voltage and amperage go on the outside of the wire. The wire itself, what it's made of, will tell you the speed in which it'll move at. Copper has a higher resistance than, say, silver. If I use silver, it goes much faster. If I wanted to create more resistance, I'd use copper. And we do experiments like this all the time. You'll see it as a big magnet. They pendulum it right to a big piece of copper and it'll stop. Has a high resistance value. But silver doesn't have it. Graphene doesn't have it. So graphene on the outside of your wire would make this go much faster. Okay, it has to be a flowing energy. Okay, it cannot be here. When we look at this, how do I want to say this? You have your dielectric. Okay, Steinmetz told you this. That goes out like this. You know there's a frequency because you're going around the wire. You're not going through it like this. That makes no sense. As soon as you go over and do that to any cylinder of any type and you start drawing something that just looks like this, you immediately know you're wrong. Immediately. If you can't figure that out, I don't know what to tell you. It goes around it. Now, Steinmetz told you that your dielectric goes straight out. What happens to your magnetic? And I want you to think about rotating magnets, but let's go to electrics instead. As I spin an electric, my magnetic field builds out from it. But what happens? It doesn't like to be there. It compresses back in. It continuously in rotation tries to push it out, and it continuously wants to come in. So right here, as we sit on this, we have a level of magnetism that keeps wanting to push back in. Now, your electrical field may go further out than this, okay? I'm not gonna lie to you there. Your voltage, just like we said, your amperage, it pulls out and then it wants to suck back in, but that's just the nature of it. It causes compression between the two. So what do you need to know? This right here. I need to know the permeability of space as I do this. Just for this very reason, the voltage and amperage, the way it works in a moving electrical field. Again, this is why they would say electricity is alive or something like that. It's because it's always in motion. So what happens to DC when it doesn't connect on a full loop? It doesn't run. Therefore, in a closed loop system, you are controlled. Now, that means that this magnets only. This is not going into an electromagnet at all. They're different. Therefore, this is exclusive to a magnet. This is not how it builds out in an electromagnet. Why do I talk about permeability of space? I build field bubbles and stuff like that, and it's a very important lesson to learn. When you get into permeability of space, you get into high voltage and low voltage. And in high voltage, it makes a lot more sense when you start to build things out because you can actually see it. We look at how Faraday was doing his experiments, and he was doing them in a high voltage nature, and he was trying to express how they work. And what you would get in this little thing here is the permeability as it goes out. You would also get the rotational nature of it. Now, if you spin this, you're going to get right here, you're going to get your magnetic field to build out. Basically, when you get into really high voltages, this magnetic field is almost null. It's almost not there. And then you go like this and you rotate and you get your, basically your voltage field builds out quite a bit. That's in high voltage, and you're able to see the difference in the two. When you get into low voltage and stuff like that in a DC closed system, it acts a little bit differently. You're able to pull the magnetic field out quite a bit more into an electromagnet. You have to remember the experiments these people did when they made these equations, and then some of them need to be updated. So let's look at this. We have the E field and we got the B field here. Now, I told you earlier, frequency, voltage, and amperage is constant in any moving voltage. It cannot be decoupled. What's the problem with going on like this? Some people think that they can be decoupled. That's a problem. When you get into further equations and you get higher into physics, it's going to become an issue for you. If you think you can cancel something out that cannot be canceled out, it becomes a problem. These should be written together. These should always be together because you cannot decouple this in an electromagnet. So they should always be written together. And if it's a magnet, it should always say magnet separate than an electromagnet. They have some of the same properties, but when it gets into nature, they're not the same. You have to understand something like this. A magnet is not the same as an electromagnet when it comes to the fields in the earth. It doesn't work the same way. Magnetic fields for a magnet has a very low potential area. It just does. It has a very low potential field. It'll only go so far. But when you get into high voltage, you could take that same electromagnet and start changing it now and make the field much bigger. Let me just show you something, and I learned this a long time ago. If you want to structure voltage in a bubble or a field, you have to know what you're looking at. So let's do this. I need magnetism to be here. So this is my magnetism right here. I need right here my high voltage. I need right here that's my sheath. What do you need for a sheath here in the open air? Impulse. Why? Because impulse energy is much stronger than pulsed energy. Let's just take a Tesla coil. If I were to take this Tesla coil, my pulse goes on the outside. Very weak field, drops off really quick, just like a magnet. If I drop a rod right down the center, I get the impulse. It is a corrective field to the pulse. It pulls in, okay? It's pulling it in and it's tightening and it's holding it. It's causing compression. Now I can build my field because my sheath is built from this. It's built from an impulse. I have a magnetic value. I have a high voltage value. I simply need right here a node. I just need a node. Why? Because I must be able to pull in energy outside of this field. If I get a node here, I get a vortex here. Now, what does that vortex do? It pulls in the surrounding environment, drops it back this way. We're pulling it in. We're driving it into here. Now, this bubble here will increase right there. I can now increase that. If I use this, if I use the pulse, this would be absolutely garbage and never work. There's a major difference in understanding pulse and impulse when it comes to field bubble. Understanding how an electromagnet actually works changes how it works in nature. This becomes one of the most important parts that you need to know. If you want 0 point, you must use an impulse. You must understand the fundamentals of actually how energy works. That magnets are not electromagnets. They are completely separate. They have different values. They work on different things. If you want to understand this further, you must understand the entropy state that you're in. You also must understand that every value that builds out in a spinning magnet or an electromagnet has a radiant value to it. Whether it goes to radiation or not, okay, or it just stays in the radiant nature, it has it. Why? We already know this. It's the field, the outside field. We are in an impulse radiant energy field. That's what we're in. We're saturated in it. So people try this all the time. And God bless you, man. I wish it worked better, but it doesn't. If I want to go over here and I just want to use, say, mostly electricity, right? So I'm going to go a frequency and I'm going to go, my voltage is really high. And I'm going to take my amperage and drive it really low. Okay? Now I basically have static electricity. And I go over here to my scale. Okay? I'm going to get that thing to move maybe that much. Yeah, okay, well, let me just reverse that, okay? I'm going to take my frequency and I'm going to take my voltage and I'm going to drop it down to nothing. I'm going to take my amperage, I'm going to run it through the roof. I get the same value. You go, well, those two things sucked. How do I interact with the field? Well, you got to interact with the portion of the field that you can. You must now create your impulse, okay? Or we can even go, no, we'll just stick with this. We'll just go create our impulse, right? Now, am I going to mess with this scale when I do this? Let me just give you the correct understanding here. As soon as you created the impulse and you created the outside field, you are no longer part of the field that's all around you if you did it right. If you did it wrong, you're still part of it. You used the pulse and you incorrectly understood everything. You did everything in hot energy and you failed. And that happens a lot. I see it a lot in papers. You completely failed. You didn't use the negative impulse because you thought the signs were interchangeable, but they're not. Why? Because nature itself told you the outside field that you're in is negative radiant energy, and you didn't listen. When I create this, and I create this field bubble, That's no longer a factor. All these things, no matter which one you create, and I don't care, they'll give you a little bit of movement on a scale, but they won't give you any more than that because you're not understanding the problem properly. The problem is the energy all around you is way too high. You'll never reach the potential energy of the earth, ever. You have to decouple from it. You have to create a bubble from it. Then you can draw that energy in. Why is it an impulse? Because the impulse interacts with that energy. That's what you have to understand. You have to be able to interact with that energy. A pulse will not do that. It'll dissipate too fast over time. It'll be an absolute garbage field. Don't even bother trying it. Let me just tell you that. It's for the same reason that even if you take a magnet and you put a rod through it and you make their forces propel against each other, okay, and you drop it, you're only going to get this scale part here. You'll never get what this brings you. You'll get the scale part, you'll never get what this brings you. Why? Because you're not interacting with the earth properly. You did not understand what was there. You did not understand entropy. You did not understand the radiant value. You did not understand the structure of the bubble you needed to build. I say all this to make you guys understand something. Some of these equations are good. Some of them are bad. Some of them need to change. They should be updated. We know a lot more than what, the 18th, 19th century that they came from. We should do our due diligence and write them correctly. That way, we don't have people misunderstanding them all the time. We don't have people that'll look at them and go, well, I can cancel this out. Or I could change positive and negative. You can't. Let me just explain this. Just so you understand. If you're here and you're using positive energy to push out, it is a very low yield voltage. It's very low. This out here is your negative energy, right? Where is it? For all of you out there that like to calculate things, calculate the radius of this and give me the volume of the sphere, and you tell me if that's going to be good enough. Because it's not. I must match this energy to use this energy to my advantage. This has to be my energy source. I must find a way to use energy to draw it in order to use it. This won't get me anywhere. This is horrible. This is non-passing. This is complete failure. Have to be able to interact with that. You want to tap the 0 point? That's where it is. You want to tap gravity bubbles? That's where it is. Otherwise, you're just playing around and not doing anything. Anyway, hopefully I explained it well enough that you guys will understand it. I really would like everybody to succeed. Look into what I said. Instead of just putting in a Tesla coil for energy, ask it about the impulse of the Tesla coil. Okay? And when you get to your AI and it starts arguing with you, you make sure you put down the point that it's impulse. And then a whole new field will open up in your AI and they'll start telling you, oh, well, they use impulse fields all the time. And they're a much stronger field than a regular pulse field. And you go, what? Why wouldn't you just tell me that in the beginning when it comes to Tesla coils? And it's because they don't want you to know. That's it. And rare few do. I don't know how many people will pick up this whole thing here and understand it and build the field bubble. But that's what you have to do. If you get into basically your nodes and you want to expand your nodes and get more energy come through, that coil must become a pump. It must now pump things. And you go, what do you mean? Well, it's an energy pump. Tesla showed you this. You see him with a little figure where he's going like this to the earth and he's pulling the little pump. Why is he doing that? Because he's pumping the earth from energy. He's using the energy of the earth. He's not out there building energy and pushing it out. He's pulling in the energy of the earth. That's what he did. That's what he learned. He learned the impulse was much stronger than the pulse, and he was able to deliver that in Wardenclyffe Tower. Heck, we have it in ancient Egypt and all of the pyramids that are going on there. The Great Pyramid, how do you think it worked? It pulled in the energy from the sky, brought it down to the water table and distributed it, and multiple ones doing the same thing will continue to do that as a grid around the earth. That's not hard, it's just ancient technology. But if you don't understand the impulse of anything, you'll never understand it. It'll just, oh my God, another crazy guy talking. Anyway, I thank everybody for watching. I hope you understood it. Maybe I could be clearer next time, but there it is. I hope it finds you well. Thank you very much. Have a great day.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.